Welcome to our first video in the discussion of the Individual Readiness Assessment Test for Section 10.1 on sequences. In this video, we'll talk about terms and definitions as well as the answer to question 1. What is a sequence? A sequence is simply a list. It could be a list of real numbers. It could be a list of functions. We often denote a sequence by putting the term inside braces and indicate where the index begins, in this case n equals 1 to infinity, and we can list out some of the terms, a sub 1, a sub 2, a sub 3, and we state that that continues. For example, I could have the sequence n divided by n plus 1, where n begins at 3 and continues until infinity. So if n equals 3, I have the term 3/4. If n is equal to 4, I have 4/5. And if n is equal to 5, I have the term 5/6, and that pattern would continue. Again, these items would be considered terms. I could also define a sequence recursively. That means that if I have given one or more terms that are known, I could find the next term in the sequence, and I would have to be given some initial terms. So for example, if a sub 0 equals 4, and I know a sub n plus 1 equals the square root of n plus 1, then I would get a sub 1 by taking the square root of a sub 0 and adding 1. Or in this case, a sub 1 would be the square root of 4 plus 1, which would be 2 plus 1, or 3. A sub 2 would therefore be the square root of a sub 1 plus 1. So that would mean that a sub 2 is the square root of 3 plus 1. A sub 3 would be the square root of a sub 2 plus 1. So that means that a sub 3 would be the square root of the square root of 3 plus 1 plus 1. And that pattern would continue. Alternately, I could say that a sequence is a list of functions. For example, I could have the sequence of functions f sub n, where n begins at 1 and continues to infinity, and maybe I want my list of functions to be 1 over x, 1 over the square root of x, 1 over the cube root of x, and so on. In which case, I would say that my list of functions would be x to the negative 1 over n, where n begins at 1 and continues to infinity. We say that a sequence converges if the limit of the terms as n goes to infinity equals L. In other words, the terms as n gets very, very large approach 1 and only one number. And when n is very large, a sub n is very close to that number. Again, we can return to our example of n over n plus 1, n beginning at 3 and continuing to infinity, and we said that this was 3/4, 4/5, 5/6, and so on. If I want to take the limit as n goes to infinity of n over n plus 1, we can see that that limit would be 1. So we would say that the sequence of n over n plus 1 as n goes from 3 to infinity converges to 1. Okay. Similarly, we can say that a sequence diverges, and if you recall from Math 165, Calculus 1, the limit of a sub n as n goes to infinity would either not exist, so maybe the terms never settle down to one number, maybe they oscillate, or maybe the limit of the terms as n goes to infinity is either a positive or negative infinity. Okay, and again, an example could be negative 1 to the nth power, and n begins at 1 to infinity. So this would be when n is equal to 1, we would have negative 1. When n is equal to 2, we would have negative 1 squared, which is 1. When n is equal to 3, we would have negative 1 cubed, which is negative 1. So we would have the sequence -1, 1, -1, 1, and so on. And we would say that the limit of this sequence, -1 to the n, as n goes to infinity, does not exist. We also talk about sequences being bounded. A sequence is bounded above if there is some number m such that all the terms are less than or equal to that number m for all the terms of the sequence. Okay. We would say that a sequence is bounded below if there is some number m such that m is less than or equal to the terms for all n equal 1, 2, 3, and so on. So for example, I might consider 2 to the n going from 0 to infinity, and this would be 1, 2, 4, 8, 16, the powers of 2. Is this sequence bounded above? The sequence is not bounded above, because for any number m, so for example 1000, is there some n such that 2 to the n is bigger than 1000? Well, sure. At some point we know that there's a 2 to the n such that we actually get 1024, right? Is it bounded below? Yep, it's bounded below. In fact, we can say it's bounded below by 1. Because 1 is less than or equal to the n for n going from 1, 2, and so on. We say that a sequence is bounded if the sequence is both bounded above and bounded below. And then we talk about non-decreasing and non-increasing. A sequence is non-decreasing, or we could also say it's increasing, if the terms are at least as big as the terms progress through the sequence. Okay. So a sub n is less than or equal to a sub n plus 1 for all n. Similarly, we can say that a sequence is non-increasing or it's decreasing if a sub 1 is bigger than or equal to a sub 2, is bigger than or equal to a sub 3, and so on as n gets larger. And then we say a sequence is monotonic if it's either non-decreasing or non-increasing. So let's take a minute and let's take a look at question 1 of the individual readiness assessment test for section 10.1. So we consider the sequence a sub n, which is defined by a sub n equals n plus 1 over n, where n goes from 2 to 3 to 4 and so on. Okay. And let's address a few questions. First of all, does this sequence converge? Okay, so in order to answer that question, we ask, is the limit as n goes to infinity of n plus 1 over n, does that limit exist? Well, knowing our properties of limits, I can say that the limit of a sum is the sum of the limits, so I can take the limit as n goes to infinity of n plus the limit as n goes to infinity of 1 over n. And we know that this is infinity plus 0. So therefore, we know that the series n plus 1 over n diverges. So we can eliminate choice A. We can also ask, is the sequence, which is the sequence of n plus 1 over n, as n goes from 2 to infinity, is it bounded? can I specify some number, any number, and does the sequence eventually get larger than that? For example, if I think that the terms should stay less than 2 million, is there some n value where that a sub n and all the numbers after that are bigger than 2 million? So for example, I could say given some large value m, is there an n such that a sub n is bigger than m? Well, actually there would be. I could just say given m, I just choose a sub m because we know that's going to be m plus 1 over m, and automatically we know that that's bigger than m. So for example, like I said, if m is 2 million, a sub 2 million is equal to 2 million plus 1 over 2 million, which is bigger than 2 million. Okay, so is it bounded? Not bounded. So we eliminate choice B. Is a sub n defined recursively? Well, in order to be defined recursively, we would say that a sub n is written in terms of some operation that we perform on a sub n minus 1. And in the form that is currently written, since we have a sub n is equal to n plus 1 over n, this sequence is written in what we call a closed form. Not recursively. Okay. So now we know that the sequence is divergent. We just need to discuss, is the sequence non-increasing or non-decreasing? So we consider, what is the relationship between a sub n plus 1 and a sub n? In other words, as I go from one term to the next, what's that relationship? Well, a sub n plus 1 is n plus 1 plus 1 over n plus 1. A sub n is n plus 1 over n. And so what is the relationship between these two? Well, if it's obvious, well, maybe it's not obvious. So one of the things that we can do is we can ask, what's the relationship between a sub n minus a sub n, a sub n plus 1 minus a sub n, is that bigger than or equal to 0? And if so, then our sequence is non-decreasing. Because this would imply that a sub n plus 1 is bigger than or equal to a sub n. So let's find the difference between the two. So n plus 1 over n plus 1 minus the quantity n plus 1 over n. So we know we're going to have 1 plus 1 over n plus 1 minus 1 over n. Find a common denominator. This is going to be n over n times n plus 1 minus n plus 1 over n times n plus 1. is n begins at 2 and continues through 3 and 4. This is some number that's less than 1. So this is obviously bigger than 0. So that implies a sub n plus 1 is bigger than or equal to a sub n. So we know that the sequence is non-decreasing. So in answer to our question, we have choice C.